Hello dear students, welcome back again to study physics. The previous lesson already we explained this question. Now we're stopping this question 2. Okay, be with me to solve this question. This question we need to draw a picture to understand easily. We have a container. We have this container. It's filled by two types of the liquid. First, a container is filled with the water to depth 20 centimeter. From the bottom in here, 20 centimeter is filled by the water. So for example, this distance all is water, 20 centimeter. On the top of the water floats 30 centimeter thick layer oil. On the top of the water, so we know this is the water. Okay, the top of the water, of course, in here. So it's filled by which type of the liquid? By oil, 30 centimeter thick layer oil we have. So in here is oil, 30 centimeter. Okay. Now this is the density of the oil. Just understand the question, what the question said. What is the pressure at the surface of the water? Students, sorry. What is the pressure at the surface of the water? It means that find the pressure at the surface of the water. We know this is the water. On the surface of the water we have what? You have oil. It means now find the pressure of the oil. Find the pressure of the oil. Maybe you will confuse, Mr. How? Why we're gonna find the pressure of the oil? Because the question said find the pressure on the surface of the water. At the surface of the water you have oil, so find the pressure of the oil. Okay, the rule P naught plus rho Hg. Okay, students, to find the pressure of the oil, only two pressure can affect this oil. Sorry, I mean one pressure. Only the pressure out, you have air. The pressure, atmospheric pressure, we wrote in here, plus the pressure of the oil. Okay, the pressure of the atmospheric pressure, 1.01 times 10 power 5. Okay, and we're gonna write the density of the oil, because our purpose to find the pressure of the oil, so the density should be same, oil too. Density of the oil we have in here, look, it's written 0.17 times 10 power 3 times, and the H, the depth of the same thing, depth of the oil. The depth of the oil is 30 centimeter, make it meter, 30 times 10 power negative 2 times the G constant is 9.81. You can use calculator. Okay, let me do the calculator. Okay, first multiply the right side, that number, 0.70 times 10 power 3 times 9.81 times 30 times 10 power negative 2. So the right side answer, which is equal to 2060.1 plus, and the left side you have this number, 1.01 times 10 power 5. Now plus it at the end, plus it, plus 1.01 times 10 power 5. So the last answer, which is equal to 10306.1 by Pascal. Student, this is the last answer. Sometimes you won't get the same answer like the boot. It's quite normal, because all the answer in physics is close. We can make it close. So this is the reason. Now, in my calculator, this is the answer. Maybe in your calculator, you get 104. Still, it's right. Students, part B, what is the absolute pressure at the bottom of the container? And find the pressure in here, on the bottom. Solve this by yourself. Let be homework for you. Same thing, like part A. Question 3. We have another question. A beaker containing mercury containing mercury is placed inside the vacuum chamber. Guys, highlight this word for me. Vacuum chamber, it means atmospheric pressure equal to 0. Atmospheric pressure equal to 0. Atmospheric pressure. Why? You know what that means, vacuum chamber, especially vacuum. It means that a place, in this place there is no air, there is no oxygen, there is nothing. We cannot even breathe an oxygen there. So in this place, that means the atmospheric pressure, which is equal to 0. So you have containers filled by the mercury liquid. The pressure of the bottom of the beaker, the pressure equal to 2.7 times 10 power 4 Pascal. What is the height of the mercury? Find H. Okay. What was the rule? P equal to P naught plus rho Hg. Because you have vacuum, because we have vacuum, and we know the vacuum is 0 atmospheric pressure, so immediately cancel this. Only pressure it's left with rho Hg. Okay, the question said find H. How we can find H in here? Divide both sides by rho G by rho G. So this rho G all cancel. H it's left. H equal to this pressure equal to 2.7. 2.7 times 10 power 4 over density, but of the mercury. Be careful, because the type of the liquid in here now is not water, it's mercury. So density of the mercury is 13.6 times 10 power 3, and times G is acceleration, still 9.81. You can do calculator. So the last answer, the height of the mercury, which is equal to 0.2 meter. So this question, we have a new idea. What is so important, that atmospheric pressure equal to 0, because we have vacuum chamber. Vacuum, it means a place that there is no air, so there is no atmospheric pressure, so 0. So only rho G is left. So find H, divide both sides by rho G all will be cancelled. H is left equal to this equation. So just divide and do calculator, easy. Question 4. Question 4. Calculate the depth in the ocean. Calculate the depth in the ocean at which pressure. Look, baby, this is important, huh? Which pressure, right, pressure P, pressure yani P is equal 3 times atmospheric pressure. Atmospheric pressure yani P naught. We can make a relation by this sentence. Yani P equal to 3 P naught. How we know, mister? Because the question said, look, pressure is 3 times atmospheric pressure. Yani pressure 3 times atmospheric pressure. So we can make a relation to solve this example. Calculate depth H by this relation. Okay. Look, yalla, the rule again. P equal to P naught plus rho H G. We can add this relation. We can get the benefit according to this relation. Put it in here. P equal to 3 P naught. So if we can substitute only this P equal to 3 P naught equal. I just substitute. I just replace the value. We can get the benefit from this P equal to 3 P naught. Put it in here. 3 P naught equal. Copy this all again. P naught plus rho Hg. In math, you studied in math. If you have same letter, same value, we can move in a side. So this P naught move for the left side, because for both you have P naught, right? Okay. Write down 3 P naught. When this P naught come from the left side, become a negative P naught, right? Equal rho Hg. Okay. 3 P naught minus P naught, 2 P naught, it's left, equal rho H G. Okay, how we can find H? Find H, divide both sides by rho G and rho G. All will be cancelled. H, it's left. Write down H, which is equal to this rule, 2 P naught over rho G. Okay. 2 times the P naught is 1.01 times 10 power 5 over the density of the ocean. Now we have to write density of the ocean, and density of the ocean, which is equal to 1.025 times 10 power 3 times, and the value of G is constant, acceleration all time 9.81. 9.81. Okay, times because of the place again. Okay, times 9.81. Multiply the last answer of value of H, which is equal to 20.1 meter. Okay, so multiply the last answer. So this this idea is new. According to the question, we can make a relation by ourselves. Pressure is 3 times atmospheric pressure. يعني pressure 3 times atmospheric pressure. So put this relation in the equation, P equal to 3 P naught. And because both of them you have P naught, we can move this P naught from the left side, arrange the equation, and find H. And this is about question 4. Another topic is left. We have another new topic, which is called temperature in gas. Students, before to explain this all, we have a definition of temperature. Temperature is a measure of the average kinetic energy of the particle in a substance. Guys, look, according by this temperature temperature is important for each particle, because we can measure the kinetic energy of the particle. Like how is the kinetic energy of the particle? Is it they are moving faster or slowly? By this temperature we can find the velocity or the speed of the temperature particle. Sorry, the velocity of the speed of the particle according to the temperature. How? We have this note. Look, kinetic energy predicted that temperature is proportional to the average kinetic energy of the particle. Look, students, we have a relation between kinetic energy, Ke, it means kinetic energy of the particle, is proportional with temperature. You know the meaning of proportional. It means both of them increase in the same time, or both of them is decrease in the same time. There is a relation between them. If you're gonna give the particle more temperature, for example, I would like to give the particles more temperature. I would like to give the more energy to the particle, more thermal energy. At the end, the particles are moving so faster because I give them more temperature. So the relation between temperature and kinetic energy directly proportional. Both of them increase or both of them decrease. Otherwise, if you like to give them less temperature, of course the particles are moving slowly. But if you give them more temperature, of course the kinetic energy faster moving. So here it's written, look, the higher temperature of the gas, faster particles move. So you have a strong relation between kinetic energy of the particle and temperature. If you like to give the particles energy hits. At the end, the particles moving faster. So even that's why the definition temperature, look, it's in here, it's written a measure of the average kinetic energy of the particle. So temperature important because according to the temperature we can measure the average kinetic energy of the particle. And as I told you, you mentioned, if we have more temperature we get more kinetic energy of the particle. We have this rule too. This rule important to convert the temperature by Celsius with Kelvin, or Kelvin to Celsius. TK, temperature by Kelvin, which is equal to T Celsius plus 273. For example, in exam, I'm going to give you what are the temperature we have by, for example, 20 Celsius. Convert this 20 Celsius to Kelvin. How? Only put this 20 Celsius value in here and 20 Celsius and plus it with this number 273. You can get the answer. So this rule important too. Students, we have some examples about this section reviewing. Section 3.2. Question 1. Which of the following exerted the most pressure? We have 4 part A, B, C, D. In which one of them we will get more pressure? First, let me make it part this whiteboard, this slide, because you have to solve it all apart to choose which one of them has more pressure. Part A, this for part A, that one for part B, and that one for part C, and that one part D. Okay, students, be with me to understand which one of them has more pressure. Part A, 25 Newton box. Students, we have a box. We know the box has 4 sides. 1, 2, 3, 4 sides. Each side, in here is written 1.5 meter side. The distance of each side is 1.5 meter. Guys, the box is square. All of the sides equal value. 1.5, 1.5 meter, 1.5 meter. So the distance of each other side is 1.5 meter. This box or this square. Find the pressure on this box. Pressure we know equal to force over area. So you have the force, it's 25 Newton, because Newton يعني force, over area. The area of the square, the area of the box, multiply both sides, or we can make a square. 1.5 squared. The answer equal to 11.11 Pascal. The pressure of the part A. Pressure of the part B. 15 Newton cylinder with base radius 1 meter. Again, find pressure. Pressure equal to force over area. Same thing. We have a pressure equal to 15 Newton over area. But in this case, we don't have a box. Actually, we have a cylinder. So students, at the end, look, we have this. Imagine this is a cylinder. At the end of the cylinder, we have an area, cross-section area. So we have to, instead of the area, we have to write the area of the circle, because it's like a circle. So make it pi r squared. Even if you don't know, in here we have a radius. Look. So immediately think about pi r squared. Okay. Write down 15 Newton. The value of pi is 3.14 times r radius. The r is 1 and 1 power 2. So the answer of part B, 4.8 Pascal. Okay. Part C, 25 Newton. Again, we have a box. Again, same rule. Pressure, force over area. The force is 25 Newton over the area. Again, you have a box, but now the distance of each side is 2 meter. 2 meter, 2 meter, 2 meter, 2 meter. So 2 power 2. So the answer, last answer, pressure of part C, which is equal to 6.2 Pascal. Part D, 25 Newton cylinder. Again, you have a cylinder, pressure equal to force over area. The force is 25 Newton. Area, again, because you have cylinder and you have a radius, make it pi r square. 25, the pi is 3.14 times the radius, again it's 1, make it square. So the last answer of part D, pressure, which is equal to 8 Pascal. Students, now we've got all the answer of all the parts. Which one of them has more pressure? Compare all the parts, which one of them has more value? Part A, you have 11.11. Part B, you have 4.8. Part C, you have 6.2. Part D, you have 8. So of course, part B is the answer. We have more pressure because the answer is 11.11 Pascal. So the answer, part A. Students, we have question 2. Sorry. Question 2. A water is to be pumped. Guys, we have Safi mountains. We have even some water. We need to move this water on the top of the mountains by a device, by anything, to pump this water to the top of the mountains. We have a device, we can take these waters to move it up. So inside this device, when the water goes to the up of the mountain, inside this device, there is no air. Only the waters can move. Only the waters can move to the top of the mountains. During transferring the water to the mountain, only inside this device, only you have water, because only waters can move. There is no air. So this question is directly like the previous question we solved it. You have a vacuum. We said if you have vacuum, atmospheric pressure is 0. Even in here, it isn't written vacuum. But now I'll explain for you. You can understand. Water is to pump it. We need to the top of the Safi mountain. We want to pump this water to the top of the mountain by the machine, a device. But inside this device, there is no air. So again, atmospheric pressure, we don't have atmospheric pressure, which is equal to 0. But which is 321 meter height. The H is 321 meter high. What gauge pressure is needed to the water line? Find pressure. So clear now, I think we have this device. We want to move, this is the mountain. That one is the mountain of the Safin. We have some waters in here. We would like to move these waters up to the top of the mountain by this device, this pipe, this anything. But inside the device there is no air, so atmospheric pressure is 0. Find this pressure that we can compress the waters, move it to the top of the mountains. Find the pressure that you can apply the pressure to move this water to the top of the mountain. Find this pressure, this value that we can transfer the water to the up of the mountain. So again, same rule we have, pressure equal to P naught plus rho Hg. Again, because P naught 0, because there is no atmospheric pressure, again 0, only P is left, so P equal to rho Hg. Rho, you have water, so again immediately write 1000 times H, 321 meter, times G is 9.81 acceleration, multiply all, and the last answer I'm going to write in here, the pressure 3.15 times 10 power I think 10 power 6, but let me do it calculator by myself is better. 1000 times 3 2 times 9.81. The last answer is 3.14910 Pascal. So by this value, by this quantity, we can apply pressure to move the waters to go on the top of the mountain. We have to apply this value of the pressure, then we can raise the waters to the top of the mountain. So this is about question 2. 2 questions left and finish. Students, question 3. A room on the first floor of a hospital has a temperature. In a hospital, we have a room, and this room has a temperature which is equal to 20 Celsius. We have another room in this hospital, a room on the top floor. Yeah, you have 2 rooms. Look, the first floor and the top floor. On the top floor has a temperature which is equal to 22 Celsius. In which of the 2 rooms, in which of these 2 rooms is the average kinetic energy of the particle is greater? We studied now the relation between kinetic energy of the particle and the temperature. We studied the relation between Ke, it means kinetic energy of the particle, and temperature. We studied, and even we said that if we have more temperature, we will give the particles more temperature. Of course, at the end we get a large kinetic energy. The particle is moving faster. Otherwise, if we have a less temperature, of course the particle is moving slowly. So we have 2 rooms. One of the room is 20 Celsius, the other is 22 Celsius. In which one of them the kinetic energy of the particle is greatest? Of course, the answer on the top of the floor. Why, Mr. the top of the floor? This is the answer, top, because at the top of the floor we have more temperature compared with the first floor. On the top floor, the temperature is 22 Celsius, but the first floor only 20 Celsius. Which one of them has more temperature? Top floor. So you have more temperature, of course we get more kinetic energy of the particle. So on the top of the floor has more kinetic energy because it has more temperature, which is 22 Celsius. In general, if you have more temperature, more kinetic energy of the particle. Last question about this section. The temperature of the air outside on a cool morning is 11 Celsius. We have a temperature by Celsius which equal to 11 Celsius. What is this temperature? Make it Kelvin scale. Make it to TK or convert to Kelvin scale. If you know now, if you remember, I said it's really important. Temperature of the Kelvin which is equal to temperature Celsius plus 273. We have temperature by Celsius, only put it in here, put the 11 here and plus 2 this number, the answer is 284. Because we have by Celsius, put the temperature Celsius in here and plus 2 this number, the last answer we get by Kelvin. So question 4 even finish. Students, now this lesson I'm done. We have explained all the topics about this section to most of them. If there's any question you can't tell me, write down the comments. I hope to get the benefit from all my video till now. Thank you for watching my video. Thank you for subscribing. Thank you for sharing for all. Inshallah, for the second video we'll start to explain section 3.3 fluids in motion. Thank you for all. I'm done. Have a nice day.